Hello guys, my name is Ming Hui and then welcome to my channel. Oh, I forgot to say that my message number is A202101. Today I'm going to use AutoSpy with theoretical calculations to construct circuit like first and second order filter and bandstop filter. Okay, let's start my presentations. Okay, let us look at questions one. Okay, based on the graph, we can know that the blue one is state for input, the orange line is state for outputs. So that we can get that the peak value for input is 5V, whereas the peak voltage value of output is 3V. Okay, based on the diagram, we also can know that the shape of graph is look like cos, and then the graph between them have phase difference. So that based on the calculation, before calculation, this one is a general form for the graph, general equation. So that based on the calculation, we could know that this one is the calculations. We could know that V output lead to V input by 70.53 degree. Okay, after that, before I move into the calculation for circuit component. This one is the roundly construct circuit by myself lah. So that later we want to like try it is valid or not. Okay. This area is input, whether this input is output. Okay. I use component CL. Okay. Okay, let move on. Okay, by using voltage divider, V output is equals to R over R plus impedance C times Vs. So that this is the formula for your for the equation. Yeah. So that this is the detailed calculations for the circuit. After that, we could know that CL is equal to 0.014921. So that let us make some assumptions. Assume that R is equals to 2.6 Km, so that we could find that C is equal to 5.74 times power of negative 6 farad. So that let us construct our circuit. Okay, so that firstly we want to input source first. Okay, source. Okay, sorry, is voltage. Okay, we just input here. After that we input capacitor and then resistance. And then we need to connect it by draw wire, so that we just draw and connect. The most important thing that like if we want to insert ground state so that the circuit can work, so that is the most important thing. Yeah, don't forget ground state. I just insert it here, so that after we insert the components, we want to set their values. For C1, I put 5.74 micro based on the calculations, and R1 we put 2.6K. And then for sources, the more important thing is I will adjust sine graph, and then DC I put 0, amplitude based on the question I put 5, and frequency I put 8, and then T frequency is 1 over T lah. Yeah, like we also can get from graph. Yeah, and then theta I find 0, and then phase difference I put 90, and then amplitude I put 1. Yeah, so that we want to test our circuit whether it is valid or not. We want to like by analyzing by using graph, right? So that I want to run this circuit. So I just click run, and then I use transient analysis. So stop time maybe I put transient yeah, and then type to saving maximum time set out 25 and yeah, so that for the we want to check it is valid or not, so that I just click run, and then I click I want to mention I forgot to label we input at here. Yeah, and then we output. Yeah, okay, we want to test whether it's valid or not. We just want to click run, and then firstly we want to test the voltage input, and then output we just click here. Yeah, so that the graph shape and the value is sent with the question given, so the graph is correct and valid. Okay, we also want to determine that whether it is high pass filter or low pass filter. So after that, I also before that I also construct circuit same with that. I also realized that it's a high pass filter. Yeah, this one is a high pass filter graph. Yeah, okay. What is high pass filter? In my mind, that high pass filter actually is high pass filter actually is when angular equals to zeros, capacitance approximately reach infinity, so that the circuit acts like open circuit, hence current and voltage cannot pass through. Okay, when angular approximately reach infinity, the capacitance will become zero, so that the circuit acts like closed circuit, hence current and voltage can pass through. The circuit is high pass filter. Okay. Also, we have things that the passive high pass filter is the exact opposite to the low pass filter, right? This filter has no output voltage from start from zero up to the specific cut-off frequency. Here is cut-off frequencies. The lower cut-off frequency points maybe is around 70.7% or -3 dB of the voltage gain allowed to pass. So, which means that the frequency range below this cut-off point is generally known as the stop band, whereas the frequency range above the stop point, above the cutting point, is generally known as the band pass. So it's look like. So this is the meaning of the high pass filter. Yeah, this is the Phasor diagram for the general high pass filter. Yeah. Next to our questions two. Actually, based on this graph, we could directly know that it is the circuit is bandstop filter. Actually, what is the meaning of bandstop filter? Okay, in my knowledge, I think that the functions of a bandstop filter is to pass all those frequencies from zero up to its first cut-off frequency point we know as F out, and pass all those frequencies above its second upper cut-off frequency FH, but block or reject all those frequencies in between, then the filter bandwidth BW is defined as FH minus FL. Yeah, FH minus FL is indicate like center. Yeah, so that let us construct circuit bandstop circuit based on the data and graph given. Yeah, so that for FL equals 1 and the FH equals 10 kHz. Actually, I do two formulas to find the components, and then for F equals L over 2 pi L, and then the second formula I use is dB. Yeah, I use this formula for second one. The answer for for that method I use is valid and can successfully to construct circuit with the correct component value. So that so look at the first formulas. Okay, assume I for the low pass filter, I assume for low pass filter is equal to 1.2556. I also use same value of capacitance as low pass filter, and 12.6 K ohm. Yeah, so that let us move on to another formula, and then we also difference LPF and HPF, and then this is the detailed calculations for low pass filter, and then this is the detailed calculations for a high pass filter. The value I get for LE equals to 0.2, and then for high pass also 0.2, so that the formula I use is valid. So after that, before I construct the circuit, we want to mention that actually we want to like do like construct low pass. The low pass filter and high pass filter must parallel to each other. Let us construct the circuit same method at the question one, so that we want to low pass and high pass parallel to each other, so that the circuit can work very well. And then inductor, and then yeah, this one is look like parallel to each other. Yeah, so we want to connect all components together by draw wire. Yeah, just wait a minute. This one. Yeah, just combine it. The parallel is circle, and then sorry, I just forgot. And then don't forget to put the ground state. If we know put out the ground state, the cannot work. Yeah, please keep in mind. Keep in mind. And then I'll put Okay, after that I want to label so that we can clearly send the uh see the difference. So that I want to label. I'll put input first. I put input and then output. After that I want to label high pass filter and low pass filter. Which be here is high pass and then here is low pass. After that we want to put value for our ones. I put 1256. Okay. For L I put 2.0. Also 2.0, 0.2, sorry. And then for this one I put 1.256. Okay. Yeah. And then for the we just at once SD1, we just put SD1. And then we also want to test that this circuit for for band stop filter is valid or not. So that we also want to analyze this circuit by using graph. So that we also want to operate this circuit. So that we click runs and then and for question 1 we use transient, but for question 2 we use acid analysis. So that type of sweep we use decay, and then number of point, like I just put 100k, and then 10 start frequency I put 10, and then just put bigger range, so that we could clearly see the graph. Yeah, and just put yeah. So now we try to run this circuit. Yeah, we successfully get the graph, the shape of graph, which is sent with question given. Yeah, actually, like I just enlarge here. Yeah, the band stop is around 1k hertz and 10k hertz. Yeah, and then the bandwidth also sent with the question given, so that yeah. uh, yeah. So actually, what is the concept of band stop filter? Okay, let us look at the okay. For band stop filter, also known as notch filter, when angular equals to 0, the inductance approximately near 0, the inductor acts like closed circuit so that currents can pass through all the way. Yeah, closed circuit and the current can pass through all the way. But whereas for angular achieve infinity, inductance will approximately reach infinity. The inductor acts like open circuit. So for the low part filter part is an open circuit, so that currents and voltage cannot pass through each other. It just only can pass through high pass filter one. So that we can conclude that it has zero response at middle of the band, but it has finite values at both when angular equals to 0 and then equals to infinity, so that the filter is a band stop filter. Yeah, that's all. Yeah, thank you so much for watching my presentations, and then have a nice day, and then happy Chinese New Year. Thank you.